Dr. Scott Pegau. Hello. Scott is a research program manager with the Oil Spill Recovery Institute. He has a doctorate in oceanography from Oregon State University. His work is now focused on supporting efforts to improve our understanding of the impacts of oil spills and methods to improve our ability to respond to oil spills in the Arctic and subarctic marine environment. So he's going to be speaking to us today on remotely operated surface vessel for oil spill response.
So I am going to stop my video for bandwidth purposes, but present on a joint industry project that's underway to develop a remotely operated surface vessel for oil spill response. The main task of this is to apply hurting agents and igniters for in-situ burn. The vehicle also provides remote sensing capabilities and can be adapted to other oil spill response applications. There's also development in this joint industry program for an air-launched igniter. I'm not going to cover that development in my presentation. So I was surprised that we haven't spent much time talking about the why burn or some of the basics of the herders, but I appreciate it. Our initial efforts on this joint industry project is to develop the ability to put out the igniter and the herders. And we're interested in this because burns can remove a large amount of oil. And this is particularly important in remote locations like where I live up in Alaska, where getting a mechanical response would take a significant amount of time. And if we can shift to a remotely operated system, it also reduces our need to have personnel near hazardous operations. So some basics on in-situ burning, you need an appropriate thickness and freshness of oil to get it to ignite. The efficacy we've been talking about depends on oil thickness, which can be enhanced by burn properties such as the chimney effect that Tim was talking about. The burn rate does limit the duration of burn that does not have additional fuel being added. So if it's a free-floating slick, the burn really wouldn't last more than 10 to 20 minutes, and that's based on the work that's been done to date. So why herders? The approach can work because the use of herders instead of boom to thicken the oil enough for burn, so you can use the herders to thicken it up, initiate and sustain a burn. Herders have been around since the 1970s and recently have been looked at again as a response tool in support of in-situ burn. Herders can be applied aerially or by a vessel, and the vessel can move away once the burn is ignited. So you're not attached to the boom where you actually have to stay near the fire. You can move away, and it's provides a safety measure. So there have been field tests of herders and burns in open water. In this particular case that I'm showing here, it's field results that were from a test performed in the Barents Sea in 2008. A test slick of 630 liters was dropped from the ice flow onto the water surface. So what you're seeing is the initial deployment and then spread of that oil. After it had spread out, it was the herder thick slick, was spread around the edge of the slick using a small vessel. allowed it to contract back, and then the burn was ignited. And so the burn in this case lasted about 9 minutes. And it had a documented efficiency of over 90%. It's clear that burns don't remove all the oil, but most of what is left are heavier compounds that are typically less toxic, and the soot is the other big thing that's there in the smoke plume. And that smoke plume is why burns are restricted on how close to a community they can potentially occur. So up here, there's always concern about what we are doing if we do start a burn, because of the fact that you see so much smoke. But at the same time, for us, it's really important to be able to remove the oil, particularly if we can't get equipment to it, such as some of our northern communities. So what is the need? And what we're looking at is the work that we're describing here was developed out of a joint industry project that was occurring in 2015, which tested aerial application of herders and igniters. And at that time, the igniter or the herder was deployed out of one system. The helicopter had to turn around, grab the igniter, and then go back out and ignite the fire. So it wasn't an integrated system, which required either having 2 helicopters or 2 trips by 1 helicopter. The other issue is the helitorch igniter, which is seen slung under the helicopter here, also restricts the speed at which a helicopter can travel. So the recommendation from that work was to develop a single unit that could apply herders and then ignite the slick. So the approach, a consortium of industry, government, and NGOs came together and examined potential solutions for providing an integrated system that could be safely and rapidly transported to a spill location. The approach selected was the development of a remotely operated surface vessel that could be carried against the bottom of a helicopter, carried by a vessel at sea, or launched from shore. The surface vessel also has remote sensing capabilities to guide the efforts once it's out there. So we were looking for something that was very flexible in how it could be used. In putting this together, we were looking, oops, sorry, I managed to skip a slide. So we contracted for the development and testing of this remotely operated surface vessel, and it's based on a commercial jet ski platform. The platform provides a proven vessel design that was small enough to transport, capable of traveling fast and staying on station for a long time. So, the vehicle itself has the capability of traveling up to 65 miles an hour, which is ridiculously fast for those of us who go to sea, and has a 500-mile range, or 12 plus hours of operating with the fuel that's normally carried on board. It's a vehicle that has a large payload, which allows it flexibility. With appropriate modifications, it can be remotely operated by either radio or satellite communications. It can be deployed by ship, helicopter, and hopefully in the long term, maybe even fixed wing deployments will be possible as well. It can carry enough herder and igniter materials to contract and ignite multiple slicks, and can carry the remote sensing gear to ensure that we are directing our operations appropriately. While our focus is on in situ burn, it should be clear that there are potentially many other applications of a remotely operated surface vessel. You know, the payload size allows the vessel to carry a lot of other things, such as potentially sample the slick or being remotely operated. It's also important because it allows it to work in hazardous environments where we don't want to put people. Sorry, two screens, one's always going to be wrong. The vehicle is envisioned to be transported by air or road with all the gear necessary to operate the vehicle. So the idea is that we can put two vehicles in a trailer complete with all the communication equipment necessary to operate the vehicle, satellite basis or the remotely operated systems. So the status, the system build is underway. Many of the components have been tested. Here is a short video clip of testing the ignition system taking place, and another picture of an early version of the vehicle being remotely operated on a nearby lake. We're working on the first phase of integrating the different components. We had hoped that we would be completed here in February. The cold weather down in the south has slowed things down a little bit, but we are still planning to have a testing here in early March and hope to have a workshop to introduce the vehicle to the spill community here soon. Definitely contact myself or Tim Nedwed if you're interested in seeing more once we get the system fully integrated and can show you what it looks like completed. Our goal is still to make tank tests up in Alaska at the end of May, so hopefully we can have that completed, and are shooting to try to make the Canadian MPRI work in the summer. So this is the where the vehicle looks as of mid-January. The vehicle itself is up here. We've got the top plate on, starting to get things assembled. We had to build a roll cage inside so that we could lift it. And the bottom right is unfortunately not a picture out of my window in Alaska, where this is the norm. This is down in Oklahoma, where ice isn't quite as common. And that has definitely slowed down our plans for testing here in February. So, you know, with any new development, there have been issues that have cropped up. Surprisingly enough, it's difficult to Google how to build a flamethrower or how to make gel fuel. So we've had to put a little bit more effort into creating a stable ignition system than we had originally anticipated. We had to access the vehicle control software for integrating remote operations. Things have had to be repacked to allow for lifting. And you know, we had to learn how to have a tethered UAV follow the vehicle. While issues have slowed down our efforts some, COVID-19 has definitely been the biggest impact on development, but we're still hoping to be ready early here in 2021. So should it work? You know, there have been the tests to show that hurting a open or hurting a slick in open waters can be done, and the burns are there. You know, right now the biggest question that I see left is the issues associated with permitting, and some of the things that Tim Nedwed was mentioning when he was answering questions. So in summary, the system is designed for remote or rapid deployment and can provide the herders and igniters to ignite several burns. It can be rapidly deployed, has endurance and flexibility. It has the ability to take different payloads, and remote operations will allow it to operate in areas that would be hazardous to personnel. And with that, if there's any time left, be willing to take questions. What's pictured here is that handheld igniter, which is the other part of this joint industry program.
Thanks, Scott. You left us actually with quite a bit of time for questions. We don't have any in the queue, then I will ask one. But Lindsay, do we have any in the question queue?
No open questions.
Okay, then let me ask you, and maybe Tim, maybe Rick will cover this in his next presentation, but or Tim may want to weigh in. But I know one of the issues with herders in the past is that they have kind of a low action time. They're maybe effective for 20 minutes or so, and maybe not in the more advanced sea states, and so reapplications might be necessary. But I thought I'd heard that there'd been some work to make the herders have a longer functioning active time, or maybe work in more advanced swells or sea states. I mean, can you give us a sense of what progress has been made on the herders themselves?
You know, I would prefer to leave that to someone who's done a lot more work with the herders. I know that there are multiple formulations, and that one of the formulations is better. For our application, what we're looking at is we don't need to have it for a very long time, because we are planning to be able to lay the herder out. We need it to be able to work for about 10 minutes to contract the slick enough to get it ignited. And then once it's ignited, we're expecting that the combination of what action is from the herder and the chimney effect of the burn itself will help keep the burn in place. So we are not requiring, you know, it to be working for a very long period of time.
Yeah. I can see there are a couple other questions that have come in, but
Hey,
Tim or Rick?
jump in? Alan, can you hear me? Alan?
Yes.
Hey, sorry, just quickly, right? This is an important thing, because that's kind of misinformation, right? The herder that we're using, Thick Slick 6535, was developed by Garrett and Berger in the early 70s, if not late 60s. And back then, they were allowed to do field tests, right? And they actually spilled oil in the mouth of the Chesapeake Bay and used the herder formulations that they were testing. And they kept oil slicks herded for 2.5 hours in 6-foot swells with mini whitecaps.
Wow.
Right. And so, as Scott said, we don't need to keep oil herded for 2.5 hours, right? Once you herd it, you ignite it quickly with this jet ski system that we've developed, and you need tens of minutes of herding action. But the reason I wanted to mention that is because I think that evidence shows you 6-foot swells with whitecaps, and they were able to keep a slick herded on the mouth of the Chesapeake Bay, right? It's unbelievable. And they didn't go to prison for doing that, right? If you can believe it. They would now. But the point is that there may be a much bigger window of opportunity, right? There's a lot of room for a lot of research on herders, right? One of the things that's very challenging is to simulate 6-foot swells and whitecaps in a wave basin, right? Because it's wind driven waves in the basins that we can do studies on. They're paddle, you know, the waves are driven by a paddle, so you don't get the same kind of wave. And so it's not a representative system. And so I think it's possible that herders could actually have a larger window of opportunity than the fire boom systems we use now, because fire booms that are used offshore are harbor boom, right? They're not ocean boom. If you get much greater than 2-foot seas, the harbor boom are done, right? They can't keep oil in them. So I think that's one of the potential kind of exciting things that we could learn, but it's going to have to be kind of learned by experience, or we're going to have to learn by doing more field experiments, but that's quite tough to do.
Okay, thanks, Tim, for that. Looks like a couple more questions came in.
From Gina Coelho, Scott, where is the March testing to occur?
The testing in March should be occurring in Oklahoma, and it does not involve igniting oil. It is just systems tests. So being able to demonstrate that the vehicle can be operated properly. We would pump water through the system instead of igniters or the herders.
Thanks. And from Bill Adams, any thoughts on operating more than one autonomous vessel in tandem?
Yeah, you know, and I'm going to be careful not to call it autonomous because I recognize that that's quite a different thing than being remotely operated. I don't see an issue with having multiple vehicles being operated. You'd probably be using multiple operators to drive, is what I would expect.
That's all we have. Thanks.
All right. Thanks, Scott. Thanks, Tim, for contributing to that conversation.